Welcome. I'm Charles Weir of Lancaster University, and I'm presenting to you today our discoveries from a survey of Android app developers, investigating their security practices and motivations. We started by wanting to find out what real software developers were doing by way of secure programming, and why they were doing it. Sascha Fahl's team in Leibniz University, Hannover, have been scraping information from the Android App Store, that's Google Play, for several years. From the Play Store metadata, they had developer contact emails, app installation counts, and the most recent update information. They also had copies of the apps themselves. Aha, we thought. Let's compare what the developers tell us about their process in a survey with what we can find out from analysis of the app binaries. The approach, including GDPR implications, was approved by the Lancaster FST ethics panel, and we provided all the normal covering information and accountability mechanisms. Here are the numbers. Observe that we did a lot of testing and validation, 3 different kinds of pre-trial, all of which led to important changes. For example, after the face-to-face pilots, we realized that unsuccessful apps weren't interesting. So in the end, we only invited developers of apps with more than 100 downloads. We also set a limit on the time to complete the survey, so anyone who just went through ticking randomly was removed. Some apps didn't download, others we couldn't analyze, but as you see, we got enough for sensible statistical analysis. I rather like this plot of where the participants came from. KGE plots like this show the density, so highly populated Europe shows more dense than other parts of the world. In fact, the country with the most respondents was the USA, with 10%. But this shows that, despite being English language only, it was very much an international survey. So, let's look at the results. I'll discuss first the answers we got from the survey, then how some of those answers turned out to relate to each other's, then the results we got from analysing the apps themselves and how those related to the survey answers. First, the description of the survey data. We wanted to know not just what developers were doing by way of security, but why. So we asked them how important they rated various requirements. Interestingly, security and privacy rated pretty highly, with nearly half the respondents rating them as extremely important. That's more than portability or features. And, of course, we asked them what security techniques they were using. This list we asked about was based on prior work and is the key 5 most cost-effective and widely used software assurance techniques. As you see, more than half the respondents aren't using any given technique. But this graphic doesn't really tell us much, because it doesn't show whether everyone's using a different technique or whether some teams use all 5 and others use none at all. So we did some munging of the respondents' answers and produced this. These stacked bars show what proportion of respondents are using 1, 2, 3, 4, 5 techniques or none at all, and how often they do so. As you can see, about 3/4 have dipped a toe in the water by trying at least one of the techniques. And nearly half are doing at least one regularly. Of course, the results from one survey aren't very interesting in themselves, so we have to do some simple statistics to go from the proportions we measured to make pronouncements about the whole population. It's called the confidence interval for a proportion population. So, taking the 45% height of the every release or more bar here, and knowing the sample size of 335, we can do some arithmetic and deduce that the 95% confidence limit for the proportion in the wider world is 49%. Or, translating that back into normal speech, we can say if, as seems reasonable, our sample is representative, then probably less than half of successful Android developers use any assurance techniques regularly. We wondered, for the respondents using just a few techniques, which ones they were using. So we looked at the 50 or so who were using just 2 techniques, and we found this. We see they're doing the automatic code review and automatic library scan most, with some code review as well. That suggests that it's developers driving the adoption themselves, as experts would have had them doing threat assessments too. But the results do show that the impetus for security and privacy is coming bottom up from the developers, rather than top down from customers or management. Nor are the changes being driven by GDPR either. Most of the GDPR changes have been cosmetic. That may well have been the correct thing to do for any given app, but it still suggests that GDPR hasn't made much difference to app security and privacy. Now, let's move on to more beefy statistics and the relationships between the answers in the survey data. Statistics is at its best finding linear relationships. That's called regression or correlation. Of course, in real life, you don't often get nice variables ready lined up for you, and you have to construct them from other things. So here's how we munged the answers to the questions to get scores that we thought might turn out to have a linear relationship to each other. In accordance with best practice, we defined those scores and made our predictions before we did the main survey. This shows the correlations. Arrows go from probable causes to effects, with assurance technique use as both a cause and effect. Reassuringly, we found correlations between almost everything we expected, except that developer security knowledge didn't appear to be correlated with frequent security updates. When you think about it, that sort of makes sense. Of course, you can get good-looking results from extremely ropey data. So, as responsible researchers, we went back and plotted the data to see that it looked okay. Here's a couple of examples showing how the use of assurance techniques and the update frequency depend on the security requirements. As you see, it does look more or less linear. Then we check for outliers and so on. And finally, the bit you've all been waiting for, featuring software, binary analysis on actual code. We, and here I mean Ben Hermann, used 3 tool chains to analyze the downloaded apps. FlowDroid finds possibly harmful data flows leading to privacy leaks. Cognacrypt looks for cryptographic API misuse. And for HTTPS, Maladroid checks certificate validation, and we also check the server configurations for each link using the Opal framework. As the chart shows, 40% of the apps we tested had no issues from any of the tools, and roughly equal proportions had 1, 2, and 3 tools highlighting issues. As everyone knows, tools like this report lots of false positives. Our approach was to assume that reported issue counts will correlate with the numbers of true vulnerabilities, and so the counts are a proxy for those aspects of app security. Again, the values we get need some munging to get something that we might expect to vary linearly with the other measurements. In fact, the counts have a Poisson distribution. So to get something linear, we take the log. And we want a value that gets bigger with bigger security, so we use minus the log. And yeah, we found one correlation and it was backwards. We found the lack of correlation a bit disappointing, but concluded it's because the analysis tools aren't yet very sophisticated. They can't, for example, distinguish between problems in developer code and problems in libraries. And sadly, they can't detect libraries with vulnerabilities either. But looking at the one result we did get, the backwards one, we found having security experts or champions involved gave worse crypto scores. We suspect it's because we don't have a way to detect crypto not being used when it should. If security experts correctly encourage much more crypto use, you'll see exactly the effect we detected. That's, of course, the security paradox. Only those who do stuff get problems. Finally, to summarize, Here are all the important survey results in 6 bullet points. We conclude there's a great deal of work to be done to help Android developers to do better security. And finally, our thank yous. Credit to Chris, who did all the Google Play scraping and management. Dominic started the statistics analysis and did some of the images I've used in this presentation. Both qualified as authors but chose not to be, so I'm giving them credit here. Tamara reviewed the survey, Yasmin advised on the survey process, Thomas inspired the proper use of statistics with predictions, and Ian advised on the statistical analysis. And now it's over to you, and I'll be happy to answer questions.